All right, so let's break this down now. I don't know where my calculator went. I think I got a calculator. Whatever. We'll come back to it in a second. Calculator. Okay, we're gonna need this. Just want to be prepared. All right, so we got to calculate the area of a hexagon here, and this is the formula we're gonna use. We're gonna use n for the number of sides, s for the side length, that is squared, and then we're going to multiply 4 by the tangent of 180 over the number of sides. And it has told us that our area is 33 centimeters squared, which equals 6 times the side squared over 4, and I'm going to divide this out for you, times the tangent of 180 over 6, which is going to be 30. Okay. And I guess I get another one of these. So breaking this down slightly further, 33 centimeters squared equals 6 side squared. And then if I do all the math on the bottom there, so let's do, I'm going to do the tangent first. So 30 tangent I got to do on this calculator times 4 is going to give me 2.3094. And I'm actually going to hit my memory button on my calculator because I'm going to bring that back in a second. Okay, so I've got to isolate S here. This is what I want to isolate. So to do that, I have to write the following equation. S equals, since it's squared, to do the reciprocal here, I got to do a square root. And then 6 is going to go in the denominator because we're flipping it. And we've got to do 33 centimeters squared times whatever my denominator was over here. So 2.3094, etc. So popping this into the calculator, we're gonna do all of it, and then we're gonna get the square root. So I still have that value up, so I'm gonna multiply that by 33, and then I'm going to divide both of them by 6, and that will give me 12.7. And then I'm going to get the square root of 12.7, which is going to be 3.56, which I'm going to round to 3.6 for the side length. So the side is going to be 3.6 if the area is 33. And yes, there is rounding involved there. Now, in terms of drawing it, if you have a compass, so let's go back into Fusion 360. If you have a compass, there's some cool things about hexagons if they're equilateral like this that you should know. So like, if I just made a midpoint and I went out 3.6, right, centimeters, this length is going to be the same as the radius of the circle the hexagon was this. So if you have a compass, you can actually set it to 3.6 and draw a circle, and then you can actually go from one point on the circle to another point with this line to make it. Like if I took this line right here now and I rotated it, or I copied it, let's make a copy of it. Copy and paste. So like, let's say I take this line here and I snap it to the end, and see if I can get a rotation on it. Like, oh, I don't want to do it that way. Well, maybe I do. Let's put it over here. This isn't really how I ideally want to do this. Actually, I know how to do it. So like, I get this line in here, and I'm going to use a coincident constraint for here to here, and then I'm going to I want a tangent constraint, which I'm not seeing. Oh, tangent here to here, and that didn't work out because it's using the other one. Let's see if I can do a coincident from here to here. that line, I could actually draw that line and chase it around. And if you have a compass, you could actually keep doing this. So like I could copy this line again with a compass, right? And then I could do, you could just keep rotating your compass this way to make it fit into spots. Like you can take the compass and draw the circle and then go to any point on your circle, and you can kind of rotate and make marks through here. So like now if I do another one, I can go right all the way around. And it's kind of a cool way to make a hexagon. So if you want to draw your hexagon, you can do it all with just a compass and a straight edge. And you would be able to draw your shape on your thing with a compass and a straight edge. Because the length of the side is equal to this vertex right here. So from here to here is equal to the length of the side, which is also on an inscribed hexagon, the radius. So you can use a compass to do this. And that is a cool trick. I don't know if it's worth much to you, but you do have to draw this when you're done. So this is an easy way to draw it with a compass. And oops. I want this point to go here, please. Please? No, it doesn't like that. Well, whatever. This one I can just go straight across, and then this one I can match up. Okay, so that is one way to draw a hexagon that is completely equal in sides, is to use a compass. So this is number, what was that, number 8? And then number 9 I think is much easier than it may appear on paper. So let's look at number 9. Number 9 is not so much that it's difficult, it's just that it's got a lot of steps. So like for number 9, all you got to do for number 9 really is break it up into sections. So like we got section 1, I'm going to say section 1, section 2, section 3, which happens twice, so you can say section 3, section 4, and section 5. So all you got is some triangles and a half circle and a rectangle. And then you just got to break up each area. So like if I looked at this, you know, area 1, the area for 1 would be base times height. Base times height. And it says it was drawn in a 1/10 scale. So what is the actual size? And note that the sign was not drawn to scale, but drawn on a grid in which each grid is 1. So it's 1/10 scale. So each one of these grids is worth 10. So like this is 40 by 1, 2, 3, 4, 5. And if you wanted to, you could actually combine this 1 and 4 to make it easier. So I'm going to do that. I'm just going to say 1 is all of in here. So this is actually 1, 2, 3, 4, 5, 6, 7. Because that's one less calculation. So it's 40 by 70. So area 1 is 40 times 70, which is going to give me an area of 2,800 inches squared. So that's area 1. Area 2 and 3 are the same. So area 2 and 3 are equal to 1/2 base times height. And if we look at that, we've got, you know, 1/2 times 20, you know, 1, 2. As you can see from here, 1, 2. And then the height, as we can see from here, is also 20 times 20, which is going to give us, you know, 200, because this is 400 and then half of that is 200 inches. And we're going to end up doubling that. So that does end up going to 400. And then area 1, So area, I don't know, am I out of order here? Area 2, I should have said, sorry, this is just area 3. Area 2, which is this little half bubble. That's a circle, and it's half of a circle, so a circle would be, this is half of a circle, so this is half of pi r squared, which is going to give us, 1/2 of 3.14 times 20 squared. So 20 squared is going to be 400 times 3.14 times 0.5. It's going to equal an area of 628 inches squared. And then I've still got to do this triangle up front, so that is area 5 equals 1/2 of base times height, which is one half of, oh, it's going off the page, of 40 times 30. 40 times 30 is 1200, divided by 2 or multiplied by half is 600 inches squared. So I'm going to go to a new page, and I'm just going to add them all up. So I think I had area 1, which was the big rectangle. That was equal to, I said 2800. And then area 2, which was the half circle, I believe, was 628. And then area 3 were the little triangles, and I said that they were each 200, so that's going in there twice. And then the final area, which was area 5, is going to be, sorry, I'm looking at my notes, was 600. And to get the total area, you would just add all of these up. So 8, 2, 4, and 4 inches squared. So that would be your answer for this one. All right, and that is 8 and 9. So good luck.